Hello everyone, welcome to the video on Mathematics 10. Today we're going to learn about modeling using linear function. Before we start, you need to know certain prior knowledges. You need to know how to identify the slope and the y-intercept of the equation. You also need to know how to write the slope-intercept form of a linear equation from the graph or from the table. After this video, you'll be able to create and sketch a linear equations to model real-world word problems using initial values and constant rates. Let's try the first example question. A taxi charges a flat fee of $5.60 and $2.25 per kilometer. Write a linear function that represents the total cost in terms of the distance traveled. So before we start, we need to start by declaring the variables, which means we need to know what are the things that are changing. Well, I think it's pretty clear that the total cost is a number that changes. Well, you go more distance, the total cost changes. And the same thing for the distance traveled. Depending on how much you move, the total cost will change because of that. The flat fee of $5.60 and the rate of $2.25, they do not change. So let's start by declaring the variables. Let y be the total cost. And because we have another variable, I'm going to declare that as well. Let x be the distance traveled. After I have identified the variables and declared the variables, it's time to set up the equations. Well, for this question, it's pretty clear that we have these information, $5.60 and $2.25 per kilometer. Both of these numbers are quite obviously, the $5.60 means the initial value. The initial value is usually translated to the y-intercept, and the rate, especially the unit rate, usually means the slope of the line. So that means I have the slope and y-intercept, which means I can use the slope-intercept form. In y equals mx plus b, we can say that y is equal to m is 2.25 x plus the y-intercept of 560, so that's 5.60. And voila, that is the linear function that represents the total cost in terms of the distance traveled. Y equals 2.25x plus 5.60. Let's annotate the process now. So the first thing that I did was I identified and declared the variables. In a linear function, there will be two variables, the two things that are changing. And if I give a little point here, x is usually used for the independent variable. The independent variable is the variable that you change. So in this case, you change the distance, and the cost is changed because of that. So y is for the dependent variable. After I declared the variables, it's time to identify the numbers, the meaning of the numbers. And we have identified that 5.60, the initial value, is usually translated to a y-intercept. If you understand the meaning of the y-intercept, it's pretty obvious. The y-intercept means when x equals 0. When x equals 0, that's when you start the graph. Another thing is the rate. When you look at the rate, we're usually looking for the number that has a unit of something per something. So the moment you see the unit like something per something, it means that we're looking at the slope. So that's why I identified the slope as 2.25 and the y-intercept as 5.60. Let's look at the next question. Let's try the next question. The temperature in a freezer drops at a rate of 3 degrees Celsius per minute. After 5 minutes, the temperature inside the freezer is 4 degrees Celsius. Sketch the linear function that represents the temperature in the freezer in terms of time. Well, first we do the similar thing. We first identify the variables and we declare them. Well, I think the temperature is one of the variables and the time is another variable. We usually, when you have time, it's the independent variable. So let's say let x be, and let y be the temperature. Afterwards, let's also identify some key features. Well, I see the word rate of 3 degrees Celsius per minute. So I think we can say that the slope is equal to 3. Well, actually, if you read the word before that, it says it drops at a rate of 3 degrees Celsius. So I think we can say that the slope is -3. Afterwards, I'm looking for the initial value. Well, in this question, I don't have the initial value. We don't have that at the beginning. The temperature of the freezer is something. We don't have that information. Instead, we know that after 5 minutes, the temperature is 4 degrees Celsius. So for me, that sounds like an ordered pair of a point. When x equals 5, y equals 4. So let's write it down as x1, comma y1 is equal to 5, comma 4. So notice that instead of having a y-intercept, we have a point. And which format should we use? Well, the format of the equation that has a point and a slope is called the point-slope form, which is y minus y1 equals m times x minus x1. So plugging in numbers, y minus y1 is 4, m is -3, and x1 is 5. So the equation is y minus 4 equals -3 times x minus 5. Let's continue to sketch this. First, we need to identify the y-intercept, which means the x value is equal to 0. Let's rewrite the equation. Y minus 4 is equal to -3 times x minus 5. When x is 0, -3 times -5 is +15. And y is equal to 19. So we know that 0, 19 is the y-intercept. Similarly, let's also find the x-intercept, which means that y value is equal to 0. Once again, we rewrite the equation, and then we replace y with a 0. So now I'm going to divide both sides by -3, so it becomes +4/3 is equal to x minus 5. And adding 5 on both sides, I get x equals 15/3, 19/3. So therefore, the x-coordinate, x-intercept is 19/3, 0. I found both intercepts. Now let's plot them. The y-intercept, 0, 19, and x-intercept, 19/3, 0. And then we put a line through, and voila, we have found the graph of the linear function that represents the temperature of the freezer over time. Let's annotate the process here. So the first thing that we did was we identified and declared the variables. We did that in the previous question. And we also identified the slope. Now, the thing to note in this question is that the slope is negative. And how did I know that? Because I knew that the slope is negative because I saw the word drop. Well, you can use this for other questions too. If you see the word like drop or decrease or go down by, Well, it usually means that it's a negative slope, so we need to add that negative sign. And then we were given a point instead of the y-intercept. Well, in this question, the initial value is not given, that's why we use the point. And therefore, we use the point slope form. After that, the process is quite clear. We find the y-intercept, we find the x-intercept, and we plot the points and we put a line through them. And that is the final answer. Let's go over the vocabulary and the formula that we learned in this video. Well, the slope. Well, we know that the slope is the rise over run. Well, in the context, it usually means it's some kind of a rate of something per something, such as kilometers per hour, temperature, degrees Celsius per minute, and so on. The linear function is usually used to represent some kind of relationship between two quantities that shows a linear pattern, a line-like pattern. It's a constant change over constant change of y over a constant change of x. The initial value is usually translated as the y-intercept. So if you see the words like at start, in the beginning, then we can use it as a y-intercept. Otherwise, we have to use a point, then use the point slope form. Thank you for watching this video, and I'll see you in the next one.